class. How are ya? I hope everything's well. We are now, these are 18.3 videos. So we're finding missing sides with trigonometry. Now, trigonometry, remember, is a study a study of measuring triangles. So with trigonometry, all we're dealing with, we're kind of zeroing in on one little thing, and that is the aspect of figuring out measures of angles or side lengths of triangles. So triangles only have 3 angles and they only have 3 sides, so we're really zeroing in on a specific aspect of mathematics here. Now, with trigonometry, using trigonometry, remember that we have 3 different choices depending on the sides and the angles that we know. We have a choice of sine theta, which is if we have an angle the opposite side and the hypotenuse. We have cosine theta, and that is if we have an angle the adjacent side and the hypotenuse, or we're dealing with those 3 items. And then tangent theta is the opposite and the hypotenuse. Now remember, we have 3 unknowns that are there. We have an angle that's an unknown, and then we have 2 sides. Depending on which of the sides we are looking for or know, and the angle involved, then that tells us which of our 3 trig functions we will use in order to come up with the missing side or angle. Now, the other thing I wanted to do is give you your steps to finding a missing side. And right now we're just dealing with missing sides. So the steps are, first I would label the O, H, and A, OHA. I would label the OHAs, and specific to the angle that is known. So find the angle that's known, and then label the OAs and H's so that you know which of the 2 sides are involved. Once you know which 2 sides are involved, the next step is to figure out which of those 3 functions, which of the trig functions to use. Okay? And then after you figured out which trig function you're using, then the third step is to write the trig equation. Okay, now these are different, remember, because we're dealing with trig equations now. So we have an angle and 2 sides. One of those will be missing, and that you will have to solve for. And then after you've written the trig equation, then you're going to solve the trig equation, which is something we've been doing all year. So you should be pretty good at finding those sides using the algebra. And that's where we get back to algebra instead of the trig. Okay, so example 1. Let's see. Okay, so we were looking at example 1 to start here. We noticed that this is the side, I'm going to mark it, this is the side that we're wanting to find. That's where X is. And then this is the side that we know is 25. All right, and then lastly, this angle is what we have, and it's 42. So those are the first things we look at. We look at and we analyze. And on our step process up here, our steps were first to label O, A, and H. So we locate this angle, which is right here, and opposite is X, and hypotenuse is 25. So we have O for opposite and H for hypotenuse. Now, then we go back up and we look at remember, I'm just going to write it down, SOHCAHTOA. Remember we talked about that in Unit 18.3, SOHCAHTOA. With O and H, that's our sine. S stands for sine. So sine is opposite over hypotenuse. So once we've labeled our OHs and A's, done with that. Whoops, I meant to probably not do such a crazy thing, but at least check it that we've done that. The next step is to figure out which trig function to use, and we decided sine, so we've done that. We've labeled and figured out. Those were our first 2 steps. The next step is to write the trig equation. So our trig equation is going to be sine, and we always write which one we figured out, and that's one we had to figure out. Of our 3 choices, we figured out it was sine because we labeled opposite and hypotenuse. And then we're able to write sine. Always what follows is our angle. So sine 42. That means we're dealing with the opposite and the hypotenuse according to that specific angle that is 42 degrees. Sine 42. And then we set an equal sign and then it's opposite over hypotenuse. The ratio of those two sides, x is opposite, 25 is hypotenuse. And that is our equation. So we have written out our trig equation. That our last step is to solve that trig equation. So we want to solve for x. Okay. Now, eventually, we're going to have to use the calculator because the sine 42 is just a number. It's a ratio of the sides for sine 42, which is equal to the ratio of sides x over 25. So it is an irrational number, but it's just a number. And 25 is a number, and x is what we're solving for. Now, x is being divided by 25. So what do we do when x is being divided by 25? We multiply by 25. Right? And that undoes that. So we have x equals all of this right here, which is 25 times sine of 42. And I would write the 25 first because then it doesn't mix up with the number 42, the angle measure of 42. All right? And there's our equation. Now that we've solved that, we're just going to place that right into the calculator. So we're going to grab our handy-dandy calculator, make sure that whichever one you're using, you have sine, cosine, and tangent on them, and that means that they have those ratios pre-recorded and in the calculator already. So we'll type in 25, and then sine, and then 42, and then hit enter. And I got 16.728265, and of course it's going to go forever, that decimal, so we're going to truncate it, and it doesn't really say what, so we'll just truncate to the tenths position, one place after the decimal. So 16.7, and that's an approximate number because we had to truncate or round it, and we didn't write the whole number down. All right, and that's what you're going to do every time. So those are the 4 steps, and that's solving. So we've done our solving, and we've done our job. We've gone through those 4 steps. All right, so that's all we're going to do. Let's go on to example 2. So example 2 has this side, x, and according to this angle, that side runs right into it, so we're going to label it an A, adjacent. All right? Now, opposite that side is our 12, and that is an O. We're going to label it an O because it's opposite the angle. Okay? The hypotenuse is the one thing we don't have any numbers or any values on it. So this is an O and an A. So when we deal with SOHCAHTOA over here, O and A is tangent, isn't it? Tangent, T-O-A, TOA. So we're going to, we figured out the tangent. We've labeled OH and A's to come up with that tangent function. We know it's tangent, so we're going to write our equation. Tangent, and then always the angle next, 75 degrees, and that's going to be equal to the opposite, which is 12, over the adjacent, which is x. All right, so we've written out our trig equation. Now our job is to solve it. Now solving it, we have a little problem here. Our x is on the denominator. So in order to solve, how do we solve when x is in a denominator? We multiply by it. So we're going to multiply both sides by x. Okay, so we're going to divide out that x, and that leaves us x times the tangent of 75 degrees is equal to 12. Okay. Now, remember, tangent of 75 is a number. It's an irrational number. So we're just taking a number and multiplying it by x. And then how do we undo multiplying a number by x? We divide by it. So we're going to divide by tangent 75. All right, and that gets rid of our tangent 75, leaving us with just x. X is 12 over tangent 75. Okay. Now, I want you to notice something. When x was on, you're always going to have a function like sine 42 equal to x divided by a number, or here we have sine 42 is x over 25, and on example 2 we had tangent 75 is equal to 12 over x. If you recall, I'm going to write it out here in parentheses. It used to be tangent 75 is equal to 12 over x. All right, so in the beginning we either have x divided by 25, or a number, or we have 12, a number, divided by x. Now, when it's x divided by a number, we multiply by the 25, and we end up solving having those multiplied. Now, when it's x on the bottom, what we really do here is we just switch the x on the denominator with that tangent 75. Those two just switch. Notice here we have an x, and here we have the tangent 75, and it's a divisor. So x on the bottom, we have the number divided by the tangent function of 75, and then tangent 75 function. And then if it is x on the numerator, we have x over 25 to begin with, and we times by 25. So that's something that you can always remember. You don't have to go through these steps every time. As soon as you have x on the denominator, just switch the two, x and the tangent 75, and you are going to divide in your calculator. So 12 divide tangent 75. You can use your arrow, your N over D button if you'd like. Let's see. This gave it to me in radicals. So let me switch it. So 3.215. That's going to be approximately 3.2. All right. So that's what we're going to do. I have one more minute to teach before my stuff's going to go away. I'm going to do one more. So we have a hypotenuse, for example, 3, right? Hypotenuse, here's our angle. This side runs right into our angle that's 36, so it's an A adjacent. So we have our A and our H. That's cosine, right? So COTA, which stands for cosine of the angle. Cosine of the 36-degree angle is equal to the adjacent, 19 over the hypotenuse x. Okay? So this is divided by x. If 19 is divided by x, then we're just going to switch these two. The denominator, the x, we leave 19 alone. That number on the top stays there. We switch x equals 19 over cosine 36. And that's just solving, eliminating all the middle parts and just solving using algebra. Cosine 36. 19 divided cosine 36 is 23.485, which is about 23.5 if you round it. All right. Okay, last but not least, we have this side. These are both legs, right? The hypotenuse is over here, which doesn't have anything on it. So here is our angle 53 across from it. Opposite is x, and running right into it is A7. All right? So O and A, which one is O and A? And remember, TOA. So tangent 53 is opposite over adjacent, right? So tangent 53 is equal to our opposite x over adjacent 7. This one is a multiplier. You just multiply by 7 since the number is on the denominator. So those divide out. We are left with x equals 7 times the tangent of 53. And if we put that in the calculator, we get 9.2893, which approximately is 9.3. All right. And that's how you figure out those sides. So if you need to watch it again, whatever you need to do that. But I think if you watch the video, you're pretty well able to do the first section of the homework. Part 2, I'm going to go through these last 2 examples, which takes that information and moves it to a little bit further, a little more difficult problem. So watch this. If I were you, I would probably do numbers 1 through 7 on the homework and just get comfortable with that, and then watch the second video and do the second part of the homework after that. I think that'll work the best.